Hello everyone. Today I am going to discuss about multi-pass assemblers under the topic assembler design options. So far in our earlier discussions, we have seen how to design and implement a two-pass assembler which performs two complete scans over the source program in translating assembly language program to machine language. Later on, we have seen how a one-pass assembler translates assembly language program to machine language by performing only one complete scan over the source program with the restriction that majority of the forward references needs to be eliminated. The third option for designing an assembler is a multi-pass assembler, which has an added advantage that it allows forward references during symbol definitions to be handled. The need for a multi-pass assembler arises due to the fact that generally a two-pass assembler is not able to handle symbol definitions involving forward references. To understand this concept better, let's take an example segment with a set of three statements that is shown here in the slide. Alpha EQU beta, beta EQU delta, and delta reserved 1. As you see, the first two statements are symbol defining statements which defines the symbol alpha and the symbol beta. The alpha is given by the defining expression beta, and you see that beta is defined later in the program. Likewise, beta is defined by the defining expression delta, and delta is defined at the later part of the program. In other words, these symbol definitions involve forward references. So alpha is given by beta. Beta is a forward reference. So likewise, in the second statement, we have a forward reference to delta. So now if we make use of a two-pass assembler to translate the instructions in the source program, alpha and beta cannot be defined in pass 1. Remember, a two-pass assembler requires that all symbols are defined in pass 1. But when a symbol definition involves forward reference, a two-pass assembler cannot handle it because not all symbols can be defined in pass 1. Consider, for example, the statement alpha EQ beta. Now, to define the value of alpha as given by this instruction, we need to know the value of beta. However, beta is not known because the value of beta is given by delta, right? And delta appears at the later part of the program. So you can't assign the value for beta. So we can't define alpha as well as beta in pass 1. So unless you perform multi-pass processing over this segment of instructions, we cannot define alpha and beta. So if multi-pass processing is allowed over this set of instructions, then delta would be defined in pass 1 because the value for delta is given by location counter value. So once you know the value of delta by the end of pass 1, in pass 2 you can define beta. And once the value for beta is known in pass 2, in pass 3 we can determine the value of alpha, which means that we need to perform multi-pass processing over this set of instructions in order to define the symbols. So when I say a multi-pass assembler, remember that it doesn't mean that a multi-pass assembler has to make multiple passes or more than 2 passes over the entire program. Instead, only those portions of the program that involves forward references need to be processed in multiple passes. I repeat, a multi-pass assembler need not make more than 2 passes over the entire program. Instead, only those parts of the program that involves forward references need to be processed in multiple passes. Now, to implement a multi-pass assembler, we use a data structure, namely the symbol table. As you all know, symbol table is a data structure which is used to save symbols along with their values. So we use the symbol table in the context of multipass assembler to store all symbols which are defined and which are not totally defined. Whenever a symbol is not defined or when its value is not known, for that particular entry, we store the name of the symbol, the number of symbols in the defining expression for that symbol which is undefined. Also, we keep a list of all symbols which are dependent on the symbol whose value is not yet determined. I repeat, for each symbol that is undefined, we place its name, we place the expression that defines that symbol, we place the number of symbols that are undefined in the defining expression for that symbol. Also, we maintain a list of all symbols which are dependent on that particular symbol. The list is maintained because when the undefined symbol becomes defined at a later point, we can use its value to re-evaluate the values of all symbols that are dependent on the symbol. In order to understand this further, we will take a simple example and see how multi-pass processing works. So this is an example segment, program segment, which involves forward references in symbol definition. The segment consists of 5 statements. After the 3 statements, there are dotted dots indicating that there are few instructions in between, which we are not taking into consideration here because they are not of much interest as far as multi-pass processing is concerned. Okay, so we will be seeing how a multi-pass assembler works by considering this set of 5 instructions. Each instruction is assigned a line number for reference purpose. Also, it's given that when the line 4 is read, that is when the line buffer reserve byte 4096 is read, the location counter is 1034. Remember, we have a set of 5 instructions here. That is 5 symbols are defined, right? One is half set, second is max length, third is previous byte, fourth is buffer, and the last is buffen. All symbols except buffer is defined by the EQ statement. Okay, but the value of buffer is given by location counter and its value is 1034. This is the only value that is known. All the rest of the symbol values has to be calculated, has to be estimated. We shall proceed by beginning with the first statement in the segment, that is half set equals max length by 2. So I'll consider the processing of the first line. So before that, as I mentioned, for the implementation of multipass assemblers, we require a data structure that is a symbol table. And the symbol table holds the name of the symbol in the first column. This is a convention that we have used in processing this program segment and I follow the same convention that has been used in the textbook. The first column indicates the name of the symbol. The third column indicates the value of the symbol, or if the value is not known, it holds the expression that defines the value of the symbol. For example, here we have half set equals max length by 2. Please note the value of half set is not known because it is given by an expression max length by 2. So in the place of the value of symbol half set, we keep the defining expression that is max length by 2. Okay, so that is actually kept in column 3. The second column holds information about the number of undefined symbols in the expression that is defined in the that defines the symbol in the first column. For instance, we have in the first instruction here, the symbol name is half set, which will be kept in the first column. The value of the symbol is given by the expression maxlen by 2, which will be kept in the third column. Now, in the defining expression, we have one symbol that is maxlen, whose value is not known because maxlen comes at the later part of the program. So, number of symbols in the defining expression that is unknown is 1 because 2 is a constant. We know that 2 doesn't change, it's a constant. Only value that is unknown here is that of the symbol maxlen. So, the second column should indicate and 1, indicating that one symbol in the defining expression is unknown. The last column holds a pointer to the symbols that are dependent on the symbol that is placed in the first column. For instance, if we keep half set in the first column, the last column should indicate a pointer to the list of all symbols that are dependent on the symbol half set. We will discuss this further with the example that is shown here. So I'm showing the processing for the first line. We'll consider the processing for the first line first. The first line is half set equals maxlen by 2. So generally, whenever a statement is taken for processing, the assembler first processes the label field and sees if there is a symbol, and if there is a symbol, it enters it into the symbol table, right? So the first statement has the label field with the symbol name half set. So half set should be entered into the symbol table, and you can see it below in the symbol table. We have already made an entry of the symbol half set. Along with the symbol, what do we keep in the symbol table? We also have to keep its value. So what is the value of the symbol here? Value is given by the EQ statement, and the expression that defines the value of half set is maxlen by 2. So can we estimate the value of half set now? It is not possible to estimate the value of half set at this point because we don't know the value of maxlen. Where is maxlen defined? Please note, definition for maxlen appears only in the second line. Okay, so we can't keep the value of half set as of now. So what do? We keep that expression that defines half set in the place of the value. So I show it in the following slide. So half set is entered along with the defining expression maxlen by 2. So is that the end of it? No, we now also have to keep certain additional information so that later when the definition for maxlen is encountered, you can process half set. So what are the other information that has to be kept in the symbol table? We have to keep in the second column an information of how many symbols in the expression that defines half set is unknown. As I mentioned earlier, this is a defining expression for half set. How many symbols are undefined? Here we have maxlen, which is not known. So one symbol in the defining expression is unknown. So this has to be entered in the second column for the entry half set. So this particular slide shows the entry here. The first column is the name of the symbol. The second column indicates how many symbols in the expression defining half set is unknown. So one symbol is unknown, so we prefix with it with the ampersand sign. So this just indicates how many symbols in the defining expression for half set is unknown. The third column, as I mentioned, contains the expression defining the symbol half set that is placed in the first column. So next, we have to also keep one more information for the entry half set, which indicates how many symbols are dependent on half set. Do we have any symbols that are dependent on half set? So as of now, since we are done only with the processing of the statement half set EQ maxlen, that is the first statement, we don't find any symbol that is dependent on half set. Dependent on half set in the sense you need to have a symbol for which The operand field should have the symbol offset. So we don't have any such instructions. So the list associated with the entry offset has to be indicated with the null list, with an empty list. So I show it in the next slide. So we have entered the symbol name. We have maintained information as to how many symbols in the defining expressions are unknown. We have kept the defining expression for offset, and the last column indicates null, indicating that there are no lists of symbols. There are no symbols that are dependent on offset. Okay, so that is all with regard to the processing of line number 1. But then one information is left out here. So whenever you enter the expression that defines offset into the symbol table, if the in the defining expression, if a symbol's value is unknown, we need to enter that symbol also into the symbol table and flag it as a undefined symbol. So maxlen also needs to be entered into the symbol table, and we have to flag it with the special symbol indicating that the value is unknown. So I show it in the following slide. So we enter maxlen into the symbol table and we flag it as undefined. So maxlen is the name of the symbol, and in the value field we enter star, indicating that the symbol is undefined. So for every entry that is made into the symbol table, you have to keep two other information, that is number of symbols that are undefined in the defining expression and the list of symbols that are dependent. So now for maxlen, how many symbols in the defining expressions are not known? See, right now, please note, maxlen is not yet defined. The max definition for maxlen appears only at the later part of the program. So the second column cannot be filled now. Okay, because the defining expression for maxlen is not yet encountered. So you can't enter this second column for maxlen. The third column indicates the value which we have already entered, that is star, indicating that the value for maxlen is unknown. What about the fourth column? Fourth column should hold list of all symbols that are dependent on maxlen. Now, after looking into the first instruction, can you determine which symbols are dependent on maxlen? So please note, we have the symbol offset being defined with the expression maxlen by 2. It means that value of offset is dependent on the symbol maxlen. So you know that one symbol is now dependent on maxlen, and which is that it is offset. So you need to add this to the list of symbols that are dependent on maxlen. So I show it in the following slide. So we have entered maxlen also into the symbol table. We have flagged it, indicating that the value is unknown. Also, to the list of symbols that are dependent on maxlen, we have added one symbol, that is offset. Now, are there any more symbols which are dependent on maxlen as of now? We don't have any other symbols that are dependent on maxlen. So the list can now be terminated. There are no further symbols that are dependent on maxlen. So this is the end of processing of line number 1. So just to repeat, what did we do? We first entered the symbol into the symbol table, that is offset was entered. Value is given by the defining expression maxlen by 2. Maxlen was entered. Maxlen by 2 was entered. In this defining expression, how many symbols are unknown? We have one symbol that is unknown, so it was entered in the second column. And we maintained a list of symbols that are all dependent on offset. Since we don't have any symbols that are dependent on offset, the entry is null here. After this, we also have to enter maxlen into the symbol table, because this is a symbol that defines, the symbol offset is dependent on maxlen. So you also have to enter maxlen into the symbol table and flag it with the star, indicating that the value is unknown. Also, list of all symbols that are dependent on maxlen has to be added to the list that is associated with maxlen. So as of now, we have only offset that is dependent on maxlen. So offset is added to the list of symbols that are dependent on maxlen. Since we have only one symbol, After this, we have null. The null means that there are no other symbols that are dependent on max len. So this is the status of the symbol table after line 1 has been processed. Now, we shall proceed ahead with processing of the line number 2. The second line defines a symbol max len. Again, the symbol is defined using the EQ statement, and the defining expression is buffen minus buffer. Note that the value of max len is given by buffen minus buffer. However, at this point, we do not know the value of buffen and buffer because buffen and buffer are defined at the later part of the program. Right? Yes. So whenever an assembler encounters a source statement, it first processes the label field. In the second line, which is the label field has the symbol name maxlen. So maxlen has to be entered into the symbol table. But if you'll just look into the symbol table, please note that maxlen is already present in the symbol table. And it has a value star indicating that the value was not known. We have made this entry when line 1 was processed, right? So now, since we have encountered a statement which defines the value of max len, we have to replace this star with the defining expression. What is the expression defining max len? It is buffen minus buffer. So I show it in the following slide. We have to replace this star. Star means the value of a symbol is undefined. So we have to replace this with a defining expression for max len. How is max len defined? Max len is defined as buffen minus buffer. So I replace star with buffen minus buffer. So whenever you enter an expression that defines a symbol, you also need to keep track of how many symbols in the defining expression is unknown. For example, max len is defined by buffen minus buffer. We don't know the value of buffen and we don't know the value of buffer. So number of symbols in the defining expression that is unknown is 2. So we have to enter this in the second column as we have done here. So we have to enter it. 2 symbols in the defining expression is unknown. So 2 is entered. So is that the end of the processing? So as we have done for the first statement, now we need to also enter the undefined symbols into the symbol table and flag it as star indicating that the values are unknown. For instance, in the defining expression for max len, we have 2 symbols undefined. One is buffen and the other is buffer. So we need to enter both these symbols into the symbol table and keep a list of all symbols that are dependent on buffen and buffer. So I show it in the following slide. So I first enter buffen into the symbol table and flag it with star indicating that the value is unknown. Now, along with this, I also have to add a list of symbols that are dependent on buffer. So at this point, when line 2 is processed, which are the symbols that are dependent on buffer? We have max len, EQ, buffen minus buffer. The statement says that max len is dependent on buffen. So the list associated with the symbol buffen should have the symbol max len. Okay. So we add max len to the list of symbols that are dependent on buffen. So in the defining expression for max len, we have entered buffen. Similarly, we need to enter buffer into the symbol table and flag it with star indicating that its value is unknown. So also we have added max len to the list of symbols that are dependent on buffen. There are no more symbols that are dependent on buffen, so the list can be terminated here. Next, what do? We have to add buffer into the symbol table along with the value star indicating that the value is unknown and keep list of all symbols that are dependent on buffer. Now, what are the symbols dependent on buffer? If you see the line 2, you may see that max len is dependent on buffer because max len is equal to buffen minus buffer. So the list associated with buffer should include max len. So I have added maxlen to the list associated with the symbol buffer. This simply means that maxlen is dependent on buffen, maxlen is dependent on buffer, and the value of buffen and buffer are currently unknown. So after line 2 is processed, this is the status of the symbol table. So what did we do during the processing of line 2? We have entered maxlen that was present in the label field. The defining expression for maxlen was entered in the value field, which is buffen minus buffer. In the defining expression for maxlen, we have two symbols, buffen and buffer. Both values are unknown. So we entered 2 in the second column, indicating that two symbols in the defining expression for maxlen is unknown. So after this entry was done, we have also entered buffen and buffer into the symbol table. We have entered buffen and buffer into the symbol table, and we have flagged both the entries with star, indicating that the value for buffen and buffer are unknown. Also, all symbols that are dependent on buffen and buffer were maintained or saved in a list associated with the corresponding symbol. So we have added maxlen because maxlen is dependent on buffen. Similarly, maxlen is also dependent on buffer. So that is the end of it. We are done with the processing of line number 2. Next, moving ahead with the processing of line number 3. The line number 3 defines the symbol previous byte with the expression buffer minus 1. So again, in this case, the instruction involves a forward reference to a symbol buffer. Buffer is not yet defined. So how do we proceed ahead with the processing now? So as usual, whenever the statement is processed, we have to see if previous byte is already in the symbol table. So if it is not present, you have to enter it into the symbol table. So we have entered previous byte into the symbol table now. And what is the value? Value is given by an expression buffer minus 1. So enter buffer minus 1 in the value field, enter it into the symbol table. It's not sufficient to just enter the value. You have to say how many symbols in the defining expression are unknown. How many symbols are unknown here? One is a constant. Only one symbol is unknown. That is buffer. So you need to keep this information in the second column. So I show it in the next slide. One symbol in the defining expression is unknown, which is buffer. Because please note, buffer definition for buffer is not a 10 count. We don't know the value for buffer yet. So after this, what do? We have to maintain for every symbol that is entered, you have to keep a list of all symbols that are dependent on that particular symbol. Right now we have entered previous byte. Which are the symbols dependent on previous byte? As of now, we don't have any symbol that is dependent on previous byte. Dependency is indicated by its occurrence in the right hand side. After the opcode, it should be present. So please note, previous byte is not dependent on there are no symbols that are dependent on previous byte. So the list associated with previous byte is empty. There are no symbols that are dependent on previous byte. So are we done with the processing of line 3? No, we have in the defining expression, we have buffer that is undefined. So we need to enter buffer into the symbol table now. But please note, buffer is already present in the symbol table, right? So buffer has to be entered. Buffer is already present in the symbol table. So what do we do now? We have to, it is already entered, so you don't have to make an entry. However, please note, associated with buffer, we have a list indicating how many symbols are dependent on buffer. So earlier, when line 2 was processed, we have seen that maxlen was dependent on buffer. So we have added maxlen to the list associated with buffer. Right now, we have one more symbol that is dependent on buffer, which is that it is previous byte and its value is given by buffer minus 1. So previous byte is dependent on buffer. So you need to add previous byte to the list of symbols that is dependent on buffer. So I have to add one more entry at this point. So I show it in the following slide. Earlier, only maxlen was dependent on buffen. Now, after processing line 3, we have one more symbol, that is previous byte, that is dependent on buffer. So we have two symbols that are dependent on buffer now, because we have maxlen equals buffen minus buffer. and previous byte equals buffer minus 1. So after processing line 3, this is the status of the symbol table. So now just repeating the processing of line number 3, what did we do? First, we entered previous byte into the symbol table. We have entered the defining expression, that is buffer minus 1. We have kept information, saved information of how many symbols in the defining expression are unknown. Since only buffer is not known, you kept the value 1. There are no symbols dependent on previous byte, so the list associated with previous byte is empty. So after this is done, in the defining expression we have buffer, so we need to enter it into the symbol table, which was already entered during the processing of line 2. However, when line 2 was processed, we have kept information in the list associated with buffer saying that only maxlen was dependent on buffer. Now after processing line 3, we also have to add another symbol into the list, that is previous byte. So we have 2 symbols that are dependent on buffer. So I hope this is clear to everyone till the processing of line number 3. Next, we shall proceed with the processing of line number 4. Now at this point, we have certain information that is assumed, that is when line 4 is read, assume that the location counter is 1034. Okay, so at the point, the statement that we have here is buffer reserve byte 4096. So at this point, we know the location counter value and it is 1034. So I have shown this in the next slide. Just go through the first table here. This is simply the assembly language instructions that we have taken as an example. First column is a line number, second column is a location counter. Then we have the instructions with label, opcode and operand. So we are already done with processing of line number 1, 2 and 3. We have the symbol table here. Now we are currently processing the line number 4. And it is given that the location counter value at this point is 1034. That means at this line number, the location counter value is 1034. And what is the instruction here? Instruction is buffer reserve byte 4096. The instruction says that reserve 4096 bytes of space in the memory for the symbol labeled and label it as buffer. So at this point, when the assembler encounters this statement, what does assembler do? As usual, it will enter the symbol buffer into the symbol table if it is already not present in the symbol table, right? But please note, this is the status of the symbol table after line 3 was processed. Already we have buffer in the symbol table and it was flagged as undefined. So now what we are supposed to do, what is the assembler supposed to do now? At this point, since the value for buffer is known, buffer is given the value 1034. Location counter value is 1034. So buffer should be now placed in the symbol table with the value 1034. So as I mentioned, already buffer is there in the symbol table and it was flagged star. All you need to do now is replace this star with the actual value of buffer. So replace star with 1034. Please note buffer has a value 1034. It is given that at the time line 4 is processed, the location counter value is 1034. So I show the status of the symbol table now. After processing line 4, by the time we process line 4, we know the value of buffer. So at this point, we start getting the values for the symbols. So buffer now is no longer undefined, its value is known. Okay. So since its value is now known, you can use its value in defining other symbols. We know that there are 2 symbols which are dependent on buffer. Which are they? One is maxlen and one is previous byte. So can we go back and process maxlen and previous byte now? Yes, we can do that. So I show it in the following slide. So please note, one of the symbols that is dependent on buffer is maxlen. And how is maxlen defined? It is defined as buffen minus buffer. Another symbol that is dependent on buffer is previous byte. And how is previous byte defined? Previous byte is defined as buffer minus 1. So now, knowing the value of buffer, we can estimate each of these 2 symbol values. We can calculate max len as well as we can calculate previous byte. So I'll begin first by processing the value for max len. So how is max len defined? Max len is defined as buffen minus buffer. Please note the expression has two symbols here. One is buffen and the other is buffer. As of now, we know only the value for buffer, but we don't know the value for buffen yet. Its value is undefined, right? So since we know the value of buffer, we need to make a change in this entry of the symbol table, indicating that only one symbol is currently undefined. We already know the value for buffer, which is 1034. So please note the change that I make here is change the number of symbols in the defining expression that are unknown. How many symbols are unknown now at this point? We have only one symbol that is unknown because buffer is defined. So the change is shown in the following slide. We know the value of buffer. Buffer is 1034. So we have max len defined by buffen minus buffer. Buffer's value is 1034 and only one symbol is undefined here. Please look into the previous slide. Earlier it was 2. Now it is 1. Okay. Since now we have processed the symbol max len using buffer, we can now eliminate this symbol from the list associated with buffer. Okay, now remove max len from the list associated with buffer. So I show it in the following slide. After eliminating max len, we have only previous byte. Why should we eliminate it? Because we have already indicated that the value for max len is now only dependent on buffer because we know the value of buffer now. So we need to eliminate the list of symbols that are dependent on buffer. The first symbol that we have evaluated is max len. So you need to eliminate this. So I have eliminated max len now. Now only symbol that is dependent on buffer is previous byte. Right? Previous byte is a symbol that is another symbol that is dependent on buffer. So previous byte is given by the expression buffer minus 1. So we can use the value of buffer. Buffer is 1034 and you can calculate the value for previous byte. And please note here we have ampersand 1 indicating that the value for one symbol was unknown. Now that we know the value of buffer, you can eliminate this entry from the symbol table. And now we have previous byte equals to buffer minus 1. Buffer is 1034. 1034 minus 1 is 1033. So please look into the previous entry. We had the defining expression buffer minus 1. The value of buffer is 1034. Now since we know the value of buffer, we replace buffer minus 1 with 1034 minus 1, that is 1033. So 1033 is entered in the place of the value for previous byte. So now we have processed previous byte using the value of buffer. So since this is processed, we can now eliminate this from the list of symbols associated with the symbol buffer. All symbols that are dependent on buffer has been processed. So now you can remove previous byte. So I show it in the following slide. I have to eliminate this list. So remove previous byte from the list associated with buffer. So I have eliminated, and this is the status of the symbol table after fourth line is processed. See, currently we have learned the value of previous byte. It is 1033. Please note, there is no list associated with previous byte. As soon as you know the value for a symbol, you have to scan the list of symbols associated with that symbol and see if there are any symbols that are dependent on that symbol. Null means there are no symbols that are dependent on the symbol previous byte. So you don't have to do any further processing. So that is all with the processing of line number 4. So this is the status of the symbol table after line 4 has been processed. So now we are left with the processing for the last line, that is buff and EQU star. Now Can we define buffet? See, please note, currently we were processing the line number 4. We have entered buffer into the symbol table. And what does this instruction specify? The current location counter value is 1034. So after processing the line buffer reserve byte 4096, what is the updated location counter value? Updated location counter value will be 1034 plus hexa equivalent of 4096, right? So hexa equivalent of 4096 is shown in the last column here. It is 1000. So the updated location counter value after processing the line buffer reserve byte 4096 is 1034 plus 1000. So the location counter value for the next statement is 1034 plus 1000, which is 2034. So now we will continue ahead with the processing of line number 5. And what is the statement? Statement here is buffet EQU star. So again we have a symbol buffet here. So assembler enters this into the symbol table at this point, isn't it? So enter buffet into the symbol table. However, please note buffet is already present in the symbol table. And what is a value? Value is flagged with star indicating that the value is unknown, right? So now that the value for buffet is defined, the value for buffet is 2034. Why it is 2034? Because the statement here is buffet EQU star. It is given by the EQ statement. What does the EQ statement mean? EQ statement defines the value for a symbol, and the value is given by the operand field. Operand here is star. And what does star mean? Star indicates the current location counter value. The current location counter value here is 2034. So that is why the value for buffet at this point is 2034. Now you are ready to enter buffet into the table along with the value 2034. However, as buffet is already there, it's just a matter of replacing the star with 2034. So buffet is already present in the table. You just have to replace this star with 2034. So I have shown it here. Buffet is entered or star is replaced with 2034. So after a symbol is defined, what is the next step? You have to scan the list of symbols associated with the symbol table entry. So associated with buffet, we have one symbol that is dependent, which is maxlen. So what do we need to do? We have to evaluate maxlen, re-evaluate maxlen now, and compute the value for maxlen. Okay. So maxlen is dependent on buffet. Now we know the value for buffet, so you can calculate the value for maxlen. So how is maxlen defined? Maxlen is defined as buffet minus buffer. Please note the second column shows that one symbol is undefined. Why? Because buffer is already known, right? One symbol is undefined. Buffet, and which is that symbol? It is buffet. It was buffet. Yes. Right now, after buffet is defined, we know the value for buffet, which is 2034. Already we knew the value for buffer, which is 1034. So now you can evaluate the value for maxlen. So maxlen will be now 2034 minus 1034, right? So you can evaluate it. So none of the symbols are unknown. You can eliminate this entry. So the value for maxlen is 1000. How did we get this 1000? It is simply 2034 minus 1034. So since the symbol that is associated with maxlen is processed now, you can remove this from the list associated with buffet because we have already determined the value for maxlen. So now you remove the maxlen from the list associated with buffet. So I have eliminated this. So anything else is left out. So please note, right now we are knowing the value of maxlen. We have estimated the value for maxlen, and it is 1000. So as soon as the symbol's value is known, you have to scan the list associated with that symbol and see if there are any other symbols that are dependent on that. Now we have one symbol, that is half set, that is dependent on maxlen. So you may see that half set is given by maxlen by 2. right? So now you can calculate half set using the value of max len. Half set is dependent on max len, and what is the value of half set? It is max len by 2. So we can calculate it now. So I calculate it as value of max len divided by 2. Max len is 1000 in hexa divided by 2, which is 800 in hexa. Okay, so since the value is estimated, now the value for half set is 800. So since we have evaluated the symbol that is dependent on max len, you can eliminate this from the list associated with max len. So now you can eliminate half set. So I've eliminated it. So by this time, you may see that all symbols that are dependent on max len has been evaluated, and there are no lists associated with max len. Likewise, now we know the value of half set, and all symbols, there are no symbols that are dependent on half set as of now. So all symbols have been defined at this particular point. So this is the final symbol table that we obtain after the line 5 has been processed. So this is the final symbol table. After processing line 5, we have all symbols in the program segment being defined. So I just have consolidated all the symbols table status by the end of processing of each line. So this is by the end of processing of line number 1. What did we do? We entered half set. We entered the defining expression for half set, which is max len by 2. Number of symbols in the defining expression was entered in the second column, and the list of symbols dependent on half set was maintained. After this was done, we entered max len and we have labeled it as undefined. And all symbols dependent on max len was maintained in the list of symbols associated with max len. After processing line 2 had the symbol max len. So max len was, in the last table we had max len with star. Now star is replaced with buff-n minus buffer. Since this is a defining expression, you have to note how many symbols are undefined. So this was entered. Also, we have to enter buff-n and buffer. So buff-n and buffer was entered into the symbol table and they were flagged as undefined. Symbols dependent on buff-n and buffer were added to the list of symbols associated with buff-n and buffer. You may see it here. Max len is dependent on buff-n and buffer. So this is the end of processing after line 2. Next, moving on to line 3. Line 3's previous byte equals buffer minus 1. So we add previous byte and the defining expression is added, that is buffer minus 1. One symbol is unknown, so you add ampersand 1. There are no symbols dependent on previous byte, so you add null. Also, we need to add buffer, but buffer is already there. So what do? We add previous byte, indicating that one symbol, there is one more symbol that is dependent on buffer, which is previous byte. Earlier we had only max len. If you just go back, you may see that only max len was dependent on buffer. Now we have max len and previous byte that is dependent on buffer. So this is the end of processing of line number 3. Now going to the line number 4. At this point, you know the value for buffer. Buffer is defined at this point. So by the end of processing of line 4, we know the value for buffer, right? 1034 is entered. And what do? We go back to the list associated with buffer, that is max len and previous byte are two symbols which are dependent on buffer. So we change the number of symbols that are dependent for max len. We change it from 2 to 1 for max len. So I show it here. Say you have changed it from 2 to 1. And another symbol that is dependent on previous byte is on buffer is previous byte. So you can estimate the value for previous byte because there is only one symbol that is dependent on one symbol whose value is not known for previous byte. So you can calculate this. So we have done it here. It is 1034 minus 1, which is 1033. So this is the status after line 4 has been processed, right? One changes from the previous slide. The changes, one changes here. We have 2 changed to 1, and the second change is this. We have estimated previous byte as buffer minus 1, which is 1034 minus 1. Okay. Now coming to the last statement, which is buffend EQ star. At this point, buffend is known, so buffend is 2034. But then there was one symbol that was dependent on buffend, which is maxlen. So you go back and evaluate maxlen. So we evaluate maxlen as buffend minus buffer. So buffend is 2034, buffer is 1034. So we estimate maxlen as 1000. Also, again going back, once maxlen is known, you have to evaluate the value of half set, because half set is dependent on maxlen. So you see it here, half set is estimated as maxlen divided by 2, 1000 divided by 2, which is 800. Please note 100 divided by 2 is not 500, because the values are all in hexadecimals. So that is all about the multipass processing of the instructions involving symbol definitions with forward references. So the following 2, 3, 4, 5 slides shows the status of the symbol table as shown in the textbook. Okay, this you can just go through that. It is for the same example. The symbol table entries are shown. So please note that in the textbook they have just rearranged the symbols. I mean, the order in which the symbols are defined are just rearranged. However, you can just follow the convention that I have used here. So that is all with respect to the multipass processing or multipass assemblers. So with this, we have come to the end of the topic assembler design options. And with this topic, we have also come to the end of the assembler chapter. There is one more topic left out in this particular chapter, that is the implementation example, wherein the AIX assembler is being discussed. This is given as a self-study. So you can just go through the textbook and study the implementation of AIX assembler, which is an example for a real machine. So that is the end of module 1. Thank you.